All right, so what the whole purpose of that little GeoGebra exploration was for you to basically understand that no matter if you used a large triangle or a small triangle, when you did the sine of 60, which you guys had, actually Sam, will you tell me the two numbers you had?
3.47 over 4.
3.47 over 4, and then when you divided that, you got roughly 0.9. It was 0.86 something or whatever, but I'm just going to go to the nearest tenth. You got roughly 0.9. Okay? When you guys did the cosine of that 60-degree angle, when you did adjacent over hypotenuse, you guys got about 0.5. Okay? So it didn't matter whether you had a small triangle or a large triangle. Okay? It didn't matter the sine of that 60-degree angle, opposite over hypotenuse, the sine always ended up being about 0.9. The cosine always ended up being about 0.5. The tangent always ended up being about 1.7. Do you guys know why we all got the same answer?
Similar, don't change.
They're similar? Okay? They're similar triangle. Can you explain more? What's that similar mean?
Same shape, different size.
Same shape, different size. What about the angles?
They all have the same angle.
All have the same angles, okay? So, when you have triangles or any figures where all of the angles are the same, that means the shapes are similar, and that also means then the sides are in proportion with one another. So when you do a ratio, when you do a fraction, they'll always reduce to the same thing, okay? If this was 5 and 10 right here, this might be 25 and 50 right here. The cosine of 60 will still be 5 over 10. The cosine of 60 will be 25 over 50. They both reduce to 1 over 2, 1/2, or 0.5. Okay, so it does not matter. So that's kind of a big thing, all right? Whenever you do the cosine of 60 degrees, you will always get 1/2, no matter if you have a small triangle or a large triangle. Whenever you do the sine of 60, you'll always get about 0.9, 0.86, whatever it was. Okay? So, because the triangles are similar, anytime you have 60-degree angles and right triangles, all the angles have to be the same, so all the ratios will end up equaling out. Alright? Okay, so that was kind of finishing up that GeoGebra exercise that we did. The whole point of it was for you to understand that no matter the size of the triangle, the ratios will always end up equaling out. Okay? Alright. Our next topic here, or next thing that we need to do, is we need to define all 6 trig functions. You guys nailed this the other day. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You remembered that a little bit, but there's 3 more of them besides sine, cosine, and tangent, and they're all behind me here. I'm going to go through them. I'm also going to make sure you write down a very good definition of all 6. Okay, so here are all 6 trig functions that we will use this semester. Okay? The sine of an angle, I just picked A for my variable right now. Alright? Once you get a couple of these definitions written, it's up to you if you'd like to write all 6. I'll definitely give you time to write all 6 of them. But you can't, they just kind of repeat themselves a little bit. Or maybe you'll just do, 1 or 2 and then do a couple of the reciprocal ones. It's kind of your choice there, okay? But there are some very key things that you need to have. I'm going to ask you to define what sine represents on a quiz. And you need to give a very thorough explanation. You can't just write SOH, all right? You can't just say sine is opposite over hypotenuse, okay? When you define sine, cosine, tangent, and these other ones here, you definitely need to use the word ratio. Okay? That's a very key word, ratio. The sine of an angle A is the ratio of the leg opposite angle A over the hypotenuse, and then the other part that's really important is right back here, on a right triangle. That is only true on right triangles, which I know is kind of implied by using the word hypotenuse, because you only have an hypotenuse if you have a right triangle. Okay, but I want you to understand that sine is the ratio of opposite over hypotenuse only on right triangles. Okay? Now you'll notice a couple things here. When we write it out shorthand with equations, you'll just see sin, you know. Please don't say sin, I might pick on you a little bit, all right? It is the sine of angle A, all right? It is spelled S-I-N-E, sine of angle A, cosine of angle A, but that's abbreviated C-O-S, okay? Cosine. The cosine is the ratio of the leg adjacent angle A over the hypotenuse on a right triangle again, okay? So you got your sine, you got your cosine, you got your tangent. You see them all there. Those you already knew from geometry. If you didn't recall it, this has probably been a good enough review for you here to get that back fresh in your mind. Do you guys have any questions on sine, cosine, or tangent right now? Okay? All right. The next three are probably new to you. Okay? They are called the cosecant, secant, and cotangent. They are actually known as the reciprocal trig functions. Okay? Because they are the reciprocals of sine, cosine, and tangent. What do you guys think of when you hear the word reciprocal? That's right. Anybody?
It's like, if I remember right, which I probably don't, it's the reciprocal is where it's the fractions and when you flip it.
Okay, so give me an example of two fractions that would be reciprocal.
So like 1 over 3 and 3 over 1.
1 over 3, 3 over 1. Those are reciprocals. What did you say?
Inverse. Inverse ratio.
An inverse ratio, a lot of times what we'll even say, to use the word inverse, we'll say multiplicative inverse. Okay? A multiplicative inverse. So like 2/3 and 3/2. Those are multiplicative inverses of each other. Alright? But a lot of times with this trig, I will just use reciprocal trig functions. I'll use that word reciprocal there. Okay? Because that's all that they are. They are just reciprocals of sine, cosine, and tangent. Cosecant, CSC, the cosecant of an angle is the reciprocal of sine. Therefore, it is the ratio of the hypotenuse over the opposite in a right triangle. Okay? So cosecant is reciprocal of sine. Secant is the reciprocal of cosine. It is the hypotenuse over the adjacent in a right triangle. And cotangent, easy one to know which that one's the reciprocal of. Okay, cotangent is the reciprocal of tangent. The other two people sometimes have a tendency to goof up because the reciprocal of sine, unfortunately, is not the one that starts with the S. It is cosecant. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. Okay. So those three are probably new for you. Is that probably a yes?
Yeah.
Okay. But all they are the reciprocals of the ones you already knew. They are just reciprocals of sine, cosine, and tangent. Okay? Any questions on those 6 trig functions? we'll do just a little checking here to kind of see where you're at. Let's say I gave you this right triangle right here. If some of you are still writing, I'll give you time. I just want to kind of quick finish up this video real quick, so pay attention with me right here, and I'll give you time to finish if you're still writing the definition once I stop the video. Okay? If you look at this right triangle right here, and I asked you, what's the sine of angle B? What fraction would you say? What is the sine of angle B going to equal here? 4 over 5, I heard. What do you guys think? Agree, disagree? You like it? Why is it right?
Because it's the opposite of B is 4, and then the hypotenuse of the right triangle is 5.
Perfect. Yep, very good. He said the opposite of angle B is the 4, hypotenuse is 5, so the sine of angle B would be 4 over 5. Okay? How about somebody different? What's the cosine of angle B? 3 over 5, Sam, very good. 3 over 5, because cosine is adjacent, and 3 is the adjacent leg to angle B. So the cosine of B would be 3 over 5. How about the tangent of B? Somebody else? 4 over 3. Yep, I like it. Very good, because the tangent is opposite angle B over the adjacent. So 4 over 3. What will the cosecant of angle B be? 5 over 4. Cosecant, remember, is the ratio of the hypotenuse over the opposite. It is the reciprocal of sine. So if the sine is 4 over 5, the cosecant is 5 over 4. The cosecant is hypotenuse over opposite. Hypotenuse over opposite for cosecant. Secant of angle B, anybody? 5 over 3, because it's hypotenuse over adjacent. It is the reciprocal of cosine. And then cotangent of angle B, 3 over 4. If the tangent is 4 over 3, the cotangent is 3 over 4. Alright? It is the adjacent over the opposite. It's the reciprocal of tangent. Okay? So if I give you a picture where you have all 3 sides of a right triangle, do you feel like you could name all 6 trig functions? Doing okay? You might have to look back to recall which one cosecant goes with and which one secant goes with, but other than that, feeling pretty good?
Yeah.
Alright.